Why does this ping-pong ball float above a hairdryer? And even more surprisingly, why doesn't it simply blow away when I tilt the dryer? At first glance, it looks impossible. No strings, no magnets, just a plastic ball floating in midair. So what's really keeping it there? Let's find out. When the hairdryer is vertical, the upward drag force balances the weight of the ball. If the ball gets too close to the dryer, the airspeed becomes higher and pushes it upward. If it moves too far away, gravity pulls it back down. Now let's tilt the hairdryer. The ball doesn't fall. Instead, it moves farther away from the mouth. Gravity can be divided into two components. The component along the jet, mg cosine theta, acts opposite to the airflow. The perpendicular component, mg sine theta, tries to pull the ball sideways out of the stream. As we tilt the hairdryer more, mg cosine theta becomes smaller. That means the air doesn't need to provide as much drag force to support the ball. So when less drag is needed, the ball naturally finds a new equilibrium position farther from the hairdryer. That's why increasing the angle causes the ball to move away instead of falling. But another question remains. Why doesn't gravity simply pull the ball sideways out of the jet? To answer that, let's visualize the flow. This CFD simulation shows something remarkable. The high-speed jet continuously pulls surrounding air into itself. Air from all directions rushes toward the jet. This process is called entrainment. In other words, the jet is constantly sucking in the surrounding air. Now imagine the ball moving slightly to one side. As air rushes around the curved surface of the ball, a low-pressure region is created. That pressure difference generates a restoring force which pushes the ball back toward the center of the jet. In a way, the airflow creates an invisible aerodynamic cage around the ball. And that's what keeps the ball trapped inside the stream even when the hairdryer is tilted. But there is a limit. As the tilt angle increases, the sideways component of gravity, mg sine theta, becomes larger and larger. Eventually, the restoring aerodynamic force is no longer strong enough. Gravity wins. And that's when the ball escapes the invisible cage and falls out of the jet. If you enjoy seeing the hidden physics behind everyday phenomena, subscribe for more science that looks like magic.